Welcome back, my dear students, for the UGC lecture series on lasers and their application and the Swayam portal. Today, we are going to see very fairly detailed account of carbon dioxide laser. Why I have taken this particular laser for a very detailed lecture is this. We have seen so many lasers. There are certain ultraviolet lasers, pulse lasers, and there are low power lasers, there are high power lasers. We have seen so many varieties. For example, a argon chloride or argon fluoride laser starts somewhere in the far ultraviolet of 198 nanometer, and it is always a pulse laser. It never is continuous. That is one end. There are so many lasers we have seen. The other end is 10,600 nanometer carbon dioxide laser. This is far infrared. Let me repeat, argon fluoride, argon chloride lasers are far ultraviolet, and this is far infrared. All these lasers, ultraviolet lasers, particularly excimer or excipitor lasers, are always pulsed. They could never be made a CW laser. In contrast, the CO2 laser is something unique. It can be made to work as a CW laser or a pulse laser. That is first thing. Secondly, this we must say is the far end of the laser spectrum. There are certain lasers available in still the longer wavelength, but they are all more of experimental or laboratory models. They are not available as a commercial tool for some engineers or technologists to make use of it. So, for most of the students they do not exist, but this particular laser, carbon dioxide laser, you can find it in a smaller town, where there are many. I would expect about few hundred carbon dioxide lasers in Chennai, another 50 or 30 in Coimbatore, or about 10 or 20 in Trichy. Why I am giving all these examples are, these are first thing not expensive. All that you need to spend is about 1 lakh or 2 lakhs rupees, by which you can get a carbon dioxide laser. Why carbon dioxide laser is so cheap, why it is so common, is the one simple reason: it has a very good medical application. We will see later what are the applications. That is first fascinating thing. Second is, this carbon dioxide laser has a very versatile tool. When I say very versatile, a very high power laser, pulsed high power laser, which can produce a laser pulse of 10 kilowatt pulse energy of 500 millijoule, is like a big cannon which can destroy anything. Such a high energy, high power lasers are very, very rare. I must explain this point. For example, if you think of a neodymium laser, neodymium laser can produce laser of 10 nanosecond pulse with the peak power of 10 megawatt. This particular type of laser is called high peak power laser, but the low energy laser, because if you convert what is the energy content, this will be of the order of only 1 joule, not more, or about 100 millijoule. That is all, or that is all the energy contains power, such a high power laser. On the other hand, the carbon dioxide laser is unique. It can give a high peak power, high average power, high energy also. All these are possible with this CO2 laser. Another interesting point is, most of the lasers make use of the transition of atoms or molecule from one electronic energy level to another electronic energy level. There are very few lasers which make use of transition from vibrational energy level to another vibration level. This particular CO2 laser makes use of transition from a particular vibro-rotational energy level to another vibro-rotational energy level. This is something unique in that respect also. I would just start describing about this one. Yeah, third important is mostly the lasers are inefficient. What do you mean by inefficient? Means in terms of the energy input, in terms of the energy output, output energy is optical energy, light energy, some kind of light energy. It may be pulsed or a continuous wave, but it is optical energy, nothing more. The energy that has to be put is always electrical energy. It can be converted into an optical energy and then it can be converted, it can be used to pump certain media. For example, in a neodymium laser or ruby laser, you always start with the electrical energy available from the wall plug, where energy available as 220 volts AC 60 hertz, that is what is available. That will be stepped up in that using a step up transformer. You will get about 3000 volts, then rectify it. Eventually, you will get about 2000 volts DC, and that is a voltage used to energize a capacitor, and that capacitor, after receiving enormous number of electrical storage, it will just produce a breakdown and produce a discharge in the lamp that produces optical energy or intense flash lamp, and that flash lamp is the one which supplies optical energy to the neodymium rod. So, the step is you always start from the electrical energy converted into a stored energy in the capacitor, which is converted to optical energy in the flash lamp, and that is used to pump a certain type of medium like a neodymium or a ruby laser and all the dye lasers. That is one thing. If you look at all this one, the efficiency of laser is generally not more 1%. There are exceptions. One best exception is semiconductor laser, which has an efficiency of about 20%, even 30%. What I mean is, the toy red diode laser which you can buy for 100 or 200 rupees, you need only AAA battery, just small battery, which has a voltage of 1.5 volt. The current may be 50 or 30 milliampere, I do not remember the current, but the voltage is 1.5. Some put two of them, you will get about 3 volt. The maximum current you will get is about 10 or 15 milliampere. That is sufficient to energize a red or a blue or green diode laser, which already I have shown you at the beginning. There the conversion efficiency is about 10 to 20%. Why I say 10 to 20%? There are so many reasons for that one, but typically 10 to 20%. On the other hand, a CO2 laser, a high power CO2 laser, by the way, the diode laser will have a optical power of 2 milliwatt, 3 milliwatt, 10 milliwatt, not more. If you want to have a more power from a diode laser, what you have to do is, you can put a number of diode lasers in parallel or a series of them, then try to put all the energies together and use it for something. Even then, the pulse energy that you can get from a CW semiconductor laser will be of the order of 1 or 2 watt, not more. On the other hand, with the CO2 laser, you can get a continuous wave power of 10 kilowatt. 10 kilowatt is enormous power. That not only it is very efficient, the conversion efficiency is about 10 to 20%. People have reached even up to 25%. Let us say 10%. 10% itself is very high. This is the most efficient, most versatile, most commonly used laser. It is as useful in industrial application as much as in medical application, as much as in communication also. Why I want to bring all this together is, laser is useful in so many places, so many things. Where laser has become practically indispensable is in medical application, in certain medical application, and also in certain material processing application, and also in communication. Now, this particular carbon dioxide laser is a king in all. You can use carbon dioxide laser for open air communication. People tried that one, that is the first one. They tried for material processing, it has been very successful. It has been used for medical application, there also it is useful. Now, with all these things, now we will straight go into the actual working, what is the way it works, what is the energy levels, what is the pumping mechanism, and why it is so efficient, and why you can convert into CW mode or a pulsed mode. Okay, that the introduction is done. Now, let me go into this one. CO2 laser is the one which uses a gas laser. First thing, it is a gas laser. A gas like a CO2 has atoms, carbon and 2 oxygen atoms. It will be a dumbbell shape. C will be somewhere here, oxygen will be here, another oxygen will. So, typically it will be the shape of a dumbbell, carbon dioxide. Because of this one, the carbon dioxide laser is capable of producing vibration and also rotation. We are going to look at only the vibrational and rotational energy level, since we are interested in the laser transition relevant to this particular carbon dioxide laser. Remember, carbon has its own electronic arrangement, oxygen has its own electronic arrangement. About them we are not interested for this particular context. Coming back to this, look at the diagram shown here. In this diagram, 0.8 energy level diagram of CO2, if you look at carefully, the lowest energy level is, we have just put it as CO2. You have so many energy level, they are represented by 0, 1, 0 like that. Now, what is this one? Let me explain. To see why there are 3 numbers, these vibration energy levels are given in terms of vibrational modes. If you look at what are the vibrational modes, I have shown you the molecular energy, molecular diagram of a CO2. C is a heavy one, C is at the midpoint, oxygen is here, another oxygen is here. Because of this one, the CO2 molecule can have longitudinal vibration mode, which means, imagine I am C, this hand is O, this hand is O. So, I can vibrate like this. This is called the longitudinal vibration. Another one, I can swing my hands like this. This is called the bending mode. Third one, I can swing like this or I can swing like this. Both are swinging. Since I have got 2 ways of swinging, these are called doubly degenerate vibrational mode, bending mode. Let me explain. Degenerate means, look at this one. In this case, I am just swinging like this. This is going in the y plane, let us say. My hands are going up in the y plane. If I do this way, this becomes in the x direction. This kind of bending in 2 different planes is called doubly degenerate mode, because in both cases the energy involved will be same. Now, go to the next one. This is called asymmetric longitudinal mode. Asymmetric longitudinal mode is something a little difficult to demonstrate, but still I can show. Look at this one. If I do like this, this is called symmetric extending, symmetric stretching. I can do one more thing. Look at this, which is difficult for me. I shrink this hand, but this hand I can extend it. Look at this one. This is called asymmetric longitudinal mode. These are the possible vibrational mode. Since there are totally 4 modes, out of that 2 modes are, that is bending modes, are doubly degenerate. So, we cannot distinguish them, we are not interested in this one. So, for all our purposes you have only 3 vibrational modes. One, symmetric stretching, asymmetric stretching, and third one is bending mode. That kind of 3 types of vibration modes are represented by a diagram, by a number 0, 1, 0, something like that. Okay. There are subtle ways of calling it 0, 1, 0 or 1, 0, 0. There are so many things. Out of that, let us start on this one. Look at the diagram on the right side. 0, 0, 0, 0 on the top 0 represents the ground vibrational level of CO2 molecule. That is all. Now, look at this one, how we do laser action in a CO2 molecule. We need to have nitrogen along with this. The nitrogen molecule has energy level very well matched with the energy level of 0, 0, 1, which is on the top, which is called upper laser level. Nitrogen molecule, when it is in the excited during electrical discharge, will not come down to the ground state, because nitrogen is a symmetric molecule. Nitrogen N2, which is symmetric, due to certain selection rule process, which is totally quantum mechanical. Unless you know all those details, you will not be able to understand. That kind of special type of nitrogen molecule cannot come down to the ground state producing a photon. Since it cannot come down producing a photon, it will be running around in the discharge tube angrily here and there. It is something, some people who will get angry, but they will not express their anger. They will be angrily going here and there. At that time, if somebody hits on them, they will shout at him. That happens. If you go to the bus stand, you will see such an incident, or in any crowd you will see that one. In a similar fashion, nitrogen, excited nitrogen, is called the metastate nitrogen, which will be running back and forth in the discharge tube. Take 7 times of nitrogen molecule, have 1 CO2 molecule inside. That is all, the starting point. Let me repeat. You take a discharge tube. I hope I will show the picture. Okay. As shown in the picture, in a discharge tube of about 2 centimeter or 1 centimeter diameter and the length of about 1 meter, you have, first thing all that you do is apply some vacuum tube, empty it, just remove all the air inside, then fill it with the nitrogen and also CO2 in the pressure ratio of 7:1 or 5:1, typically 7:1. The total pressure inside can be typically about 10 torr. Remember, 760 torr is a normal atmospheric pressure, and what we are having is a low pressure of 5 to 10 torr. This is a typical range. Then apply a voltage. Apply a voltage of about 1000 volts. a discharge will occur. When there is a discharge, you will have electron running from negative to positive. During this transit, they will hit nitrogen molecule and also CO2 molecule. Remember, it can hit both, but CO2 molecule is low in number in the concentration, but most likely it will hit nitrogen molecule, more likely, more probably, let us say. Then nitrogen molecules got hit, so it is very angry. From there, it will transfer its energy very efficiently, very much like helium transferring its energy to neon gas in the helium neon gas laser. Here it is always a nitrogen CO2 laser. Nitrogen plays a very little role beyond producing or hitting CO2 molecule. So, now the uppermost vibration level 001 vibration level of CO2 has been produced, or CO2 has been excited to that level. From there, it will go so many transition. Out of that, 10.6 micron transition is the most common, that is from 001 to 100. Do not worry what are these one, from one vibration mode to another vibration mode, that is all it means. That kind of transition is very efficient. So, you get a spontaneous photon. If the spontaneous photons are sufficient in number, then that will produce intense spontaneous photon. If you have two proper mirrors at the far end and they have high reflectivity, as we have described so many times, these spontaneous photons are reflected back and forth, they will produce some stimulated photon. Those stimulated photons eventually will go back and forth and they will produce more and more stimulated photons, then you will get a coherent radiation. That is the simplest story which I already have explained. Now, what is special about here is there are certain very interesting possible things are there. Now, from 001 to 100, you have very efficient spontaneous and stimulated emission from CO2 molecule. Next one, that CO2 molecule from the lower energy level will come down by collision with something else, and from there it has 2 or 3 steps to go down to the lowest energy level or the ground energy level. It is not immediate, it has to go through 2 or 3 steps. All the details I am not going to explain. In order to have the lower energy level have a 0 population, all that you need to do is you add certain gases like helium. Helium, most pacifist atom. This will never get excited, but it will have, since it will be hit by everybody. Remember, helium is a small atom, CO2 is big one. So, it is something like heavy people are going here and there in a big crowd, and the thin one is the one who will get easily hit. This is exactly what happens when CO2 molecule is the lowest energy level. If I have 10 times more helium, which will not get excited, but at the same time will get all the kicks from CO2 in the low energy level, CO2 will come down to the ground state. You see the trick. We start with the CO2 molecule alone, you can get a laser, but it will be very inefficient. To produce an efficient laser, you have to do 2 more tricks. You add nitrogen 7 times more, then you will get very good efficient production of upper laser level. That is the first step. With this, you will be able to get a very good pulsed laser, pulsed CO2 laser at 10.6 micron. People have done it. Now, in order to have CW laser, you must be able to bring back the atoms or molecules from the lower laser level to the ground level, then only they will be available for the next cycle. To do that process, you add plenty of helium, and then as I told you, helium is something which will receive the kick from everybody. It will hit with the CO2 at the lower laser level. It will get angry, but it will not do anything, it will be running here and there. So, the lower laser level CO2 will be brought down to the ground level, so that available for next cycle of operation. From this process, you can get a very efficient 20% efficient CW laser at 10.6 micron. That is all the idea, and the enormous number of technologists, scientists has worked on this one, and they have achieved as the best laser. I repeat at this point, I want to bring to focus this particular laser engineering was designed by one of our own scientists, C.K.N. Patel. He was in Bell Telephone Laboratory somewhere. He was, he won a lot of laurels. He became so important, and it was so important industrially, very useful laser. He did all these tricks. He understood this idea. He did all the trick. He produced the most efficient laser in the infrared wavelength. Now, let us go to the next important thing. Okay. All these things I have explained. So, I do not have to go into the detail. From the what is more important at this point of discussion is, from the discussion I have made so far, this is a 4-level laser. Look at this one. You can look at the diagram. The top one, you see 0, 0, 0. That level is the ground level. Then 0, 0, 1 is the number 2. This is the this is the pump level. From there, and it is same as the upper laser level also. 1, 0, 0 is the lower laser level, which is well above the ground level. And from there, you have 0, 2, 0, 1, 0. These are all lower laser levels. So, you can push the lower laser level molecule to any one of them very quickly, and because of this process, you can get very efficient laser. It is a typical efficient 4-level laser, and that is what I have mentioned here. Now, only 2 or 3 important points I must add. The upper laser level lifetime is of the order of few microsecond or even occasionally millisecond, whereas the lower laser level lifetime is of the order of 10 or 100 nanosecond, which means the lower laser level is practically empty. Upper laser level is practically full. When you have plenty of molecules in the upper laser level, practically nothing in the lower laser level, population inversion becomes very high, because N2 minus N1 is the population inversion, the delta N. Delta N is the difference between upper laser level and the lower level laser level. The lower laser level is practically 0, because of whatever is in the upper laser level is enough to produce laser action. More, it is better. Again, I can give another example. Suppose I start a business. I earn only just 500 rupees in my business, okay, but I do not spend any money. There is no wastage at all. Then every day if I get 500 as a gain, my business is a very good business, because I do not lose anything. Whatever comes, if I get every day 500, I will keep on adding up in my business. So, I will be keep on building up the profit, and my business will go up. In a similar fashion, this is the most efficient laser. Okay. Up to now, I have told you so much about the CW laser. Thank you very much.